read from left to right, we need to find the points. This is an exact point right here. And then here, to move from the first point to the second point, you're now going to have to go down. How many units? 3. And then we're now going to go to the right. How many units? So the slope, since we went down, that's a -3. To the right is +5. So now my slope, really, I can write this as, put the negative side right next to the fraction, and it's just saying that I have a negative slope. I just want you to understand that this is the same thing. It means the same thing. Okay? Alright, so if we have a negative slope, notice what is the line doing?
Going down.
Yeah. So anytime we see it's falling down, okay, or decreasing, then it should be positive. So whatever answer ratio, whatever ratio you get should match what you see on your graph. So if it's negative, then it should be decreasing. You shouldn't give me a negative answer and the line is increasing. Alright, now, we gotta talk about this. There's some extra little side notes you need to add. We're still gonna do rise over run, but on this...
Great, so yesterday you told us to write increasing line.
Yeah.
First line, is that the same thing as rising?
Right, yeah, rising, increasing, yeah. On this next line, the point is not going to rise or go down to get to the second point. It's just running. So the slope is 0 over 1, 2, 3, 4, which is just a 0 slope. Okay. This line that we have here is horizontal. Okay? There's a little acronym. I do horizontal, like such, OI, and over here we have a vertical line. The vertical line, we call that VUX, OI VUX. This acronym will help you break down these special type of lines. Horizontal lines, notice what our answer was right here for the slope? It was 0. So the O is basically saying we have a 0 slope. Horizontal lines have a 0 slope.
What's that Y for?
Well, Y is equal. When I do my equation for this line, it's Y equals the Y intercept. Okay? I just abbreviate that. So it's OI for horizontal because the slope is, the line is horizontal, the slope is 0, the equation is Y equals the Y intercept. So I look on the graph, and this graph, I go up to the Y, where it crosses the Y axis, that point is at 2, right? So the equation for this line is just Y equals 2, the Y intercept. Horizontal lines don't have an X, okay? It's going to be a constant, and it's going to be the Y-intercept. So for a vertical line, yeah, I can rise or run here. I can go down. What is it? 1, 2, 3, 4. But I have no run. It's 0. And this is important. People forget what happens when you see this 0 at the bottom. Okay? Whenever the 0 is your denominator, it's what we call undefined. Whenever you come up with the ratio in 0.
Is that what they use?
Yeah, that's what the U stands for. Yep. So for vertical lines, U is your undefined slope. And now the equation for this line is going to be X equals the X-intercept. So we go and we find, where does this vertical line touch the X-axis? right here. That x coordinate is 2. So the equation for this line would have been x equals 2. So recognizing Oivux helps you break down all the parts to the line. Horizontal, 0 slope, y equals the y-intercept. Find where it crosses the y-axis. Vertical line, undefined slope, x equals the x-intercept. Yes?
Why is your microphone?
Oh, because I'm recording the lesson. Alright, next part. I think we recorded this. This was our change in y for slope over change in x, which is also the formula y2 minus y1 over x2 minus x1. Alright, so just to help you out, just going to recap. The first coordinates here are your x1 and your y1. So label them. This should be x2 and y2. So when I'm writing and talking, you should be doing the same thing. Thank you, Nicholas. Alright, so we're going to put it into the formula. What number represents our y2? 3. So on top, we're going to do y2 minus y1. So that would be 3 minus the 1, because y1 is the 1. Okay? On the bottom, we're going to do x2 minus x1. So what number represents our x2? 8. So we're going to do 8 minus, who's our x1? 5. So x minus 5 is on the bottom. And we're just going to simplify the top, simplify the bottom. 3 minus 1 is just 2. And then 8 minus 5, 3. So my slope is just going to be 2/3. Okay, that's already simplified. It's already reduced. So sometimes labeling the points, just make sure that you substitute the parts into the formula correctly. So see if you can recognize what numbers would go on our top to represent the change in y. y2 minus y1. What would I write on top? The negative 5 minus 4. y2 minus the y1. And then our change in x, 6. Yeah, 6 minus negative 6. Make sure you keep your signs. This is going to be negative 9. This is going to be positive 12. Yeah, negative 6 minus 6 minus the negative 6. You remember you have to take keep, change, change. Keep, change, change. Some of y'all say that. Okay. Well, then just put it in the calculator. And you got the right answer though, right? Okay. Yes. Yes, I do want you to always simplify. So this can be reduced. Negative 9 over 12 can be reduced to negative 3/4. Okay. What? I don't like those little rules, but it helps people. Okay. Alright, 0 slope. I need you, we're going to add a little note to this one because there's a little pattern that occurs to help make you eliminate work. We're going to do the formula. y2 minus y1. y2 minus y1. What numbers are going to be y2 minus y1? 2 and 2. Okay. Then x2 minus x1. 2 minus, yeah, the negative 4. Alright. So 2 minus 2, that's going to give me my 0. 2 minus the negative 4, 6, positive 6. Okay, 0 over 6, or 0 divided by 6, is just 0. Okay, 0 divided by 6 is 0. Okay, now, whenever you have a 0 slope, a pattern, something happens that you can recognize real quickly. I want you to look at your your y coordinate, excuse me. What do you notice about the y coordinates? They're the same. So whenever you have the same y coordinate, guess what happens to your slope? It's 0. Because when you subtract them, you're always going to get 0. So little side note to help you. If the y are the same, then the slope is 0. I'm just saying m equals 0. The slope is going to be 0. So anytime you see the same y, you're going to have a 0 slope. What type of line would this be? Think about it. Same y. Yeah, horizontal. This would be horizontal. Okay? Then the slope. The m is your slope. Is 0. Okay, that's this one. Alright. So now on this one, the y's we can subtract because they're different. So we have -4 minus 3, but now the x's are the same. 1 minus 1. So a -4 minus 3, that will leave you a -7. Now we have 0 at the bottom. Okay, and we looked at this with our vertical line. What happens when 0's at the bottom? Yeah, it's undefined. So another way of saying undefined is no slope. Okay? And there's a pattern that occurs with this. Did y'all see how, if I look at the x coordinates, weren't the x coordinates the same? Okay? So if I have the same x coordinate, what is that going to tell me? It's undefined, okay? The x are the same. M, which is your slope, is undefined. Alright, so now we're going to look at slope is the same as rate of change. Okay, slope is the same as rate of change. Flip your book. Tell whether the rate of change is constant or variable. Well, we got to first determine the rate of change or the slope. Okay, look at this value. We're looking at inches and feet. How do we determine inches and feet? Huh? Yeah, ruler. Yeah. So, let me ask you this. Which depends on the other? Inches depends on feet. Okay, so since inches depends on feet, is inches our domain, our x, or is it our range, our y? It's our y. So this is y, this is x, okay? We got to first identify which is the x, which is the y. Alright, then we're going to look at the change between them, because slope, or the rate of change, is the change in y compared to the change in x. Alright, so it goes to 12 to 24, that's plus 12, right? Then 24 to 48. Isn't that plus 24?
Yeah.
Yeah. Then 48 to 84. 48 to 84. Plus what? 36. Right? Does that make sense? Okay. Alright. Then 84 to 108. Plus what? Isn't that 24? Isn't that 24?
Yeah.
84 plus 24 is 108. It's not the same every time. You gotta check the change, okay? Alright, now, here 1 and 2, yeah, that's plus 1. 2 to 4, that's plus 2. 4 to 3, plus 3. And then 7 to 9, plus 2. Okay, so you gotta first look at your changes in your values in the table. And we're gonna look at the change in y over the change in x. We're going to compare them. So let's look at our first one. It was plus 12, then plus 1. So that's just 12 over 1, right? That just equals 12. So that's then I look at the next one. 24 to 2, right? What does 24 over 2 get reduced to? It's also 12. Okay. Then I go to the next one. We had 3, right? That's also 12. Okay. And then the last one we had was 24, and I'm running out of room, and 2. Again, that was 12, right? Do y'all see that the change is all the same? It's a constant change. Alright, so because all the ratios, all the change between the y and x is the same number, this is called a constant. Okay? Because it wants you to determine if the rate of change is constant or variable. Now, distance and time. Who's the dependent? Who's the independent? Who's the x? Who's the y?
Time is the x, is the y.
Yeah, y and x. There we go. Alright. No, that's why you have to check it. Because sometimes they could put the x first and then the y. That's why you compare it. Well, it's not. Well, yeah, usually, yeah, you're right on that. Yeah. Okay, so 12 to 38. 26. Then 1 to 2, that's plus 2, right? Okay, so I'm just going to check that. 26 over 2. What would that reduce to? 13. Okay, now let's check the next one. We went from 38 to 90.
52.
That's 52. All right. And then we went to 3 to 7. 4. Okay, so we're going to check that one. 52 over 4. What does that get reduced to? 13. All right. Then we go 90 to 108. That's plus 18. Then I go 7 to 8. 1. And then I have 18 over 1. What does that reduce to? 18. Okay, are these the same?
No.
No. So, sorry, that's 18. Alright, so because they are different, this is a variable. The unit rate or the rate of change is variable. It has to all be the same for it to be a constant rate of change. Alright, you're going to be responsible for the next two, I'm going to stamp your answers for example 3 and 4, and then your graph and your slope on example 5. So you need to plot the points in your graph and do exactly what we just did, finding the rate of change from the table. Okay, most of you had your 3 and 4 example correct, and you were able to go ahead and plot the points to a 60, and then just make sure we don't have a misconception. And so when you connect them, alright, some of you are using, because you have to use an exact point, so I saw us use this 2 and 60, and 4 and 120. And so we counted, some of you counted and you said 1, 2, 3. Yeah, that's 3 spots, but each unit, you got to look at your scale. Each time I go up, that's 20. Does that make sense? Because 60 to 80 is 20, 20, 20. So this is, right here, 60. And this is a scale of 1 over 2. So your rate of change, which is the same as your slope, would be 60 over 2, which is just 30. So on the next part, oops, not let me do it. Alright, unit rate. Unit rate is just finding a rate in which the second quantity of the comparison is 1. So, if I have 120 bottles for 6 cases, they want to know if it's just 1 case, how much it would cost. So you can do a proportion, or you can just divide. So what is the unit rate for bottles and cases?
20.
Yeah, 20 bottles per 1 case, okay? Same thing, $84 for 4 books. What's the cost for 1 book?
20.
Yeah, 21. Yeah, like I wanted to find the cost or the amount for one. Okay. Yeah, because I just divided to figure out how much one book would cost. Yeah, 21. Yeah. So same thing here. Pay attention to your scale though. It's your change in Y over your change in X. So pay attention to your scale. Okay? So like when I rise up from 50 to 150, that's a rise of what? 50 to 150. That's 100. And then my time is 1 unit each time, so this is over 2. So 100 over 2, my unit rate would be, 50 over 1, which is the same as just 50. Okay, so this is pretty much what you're going to do now. Is you're going to finish the last 2 pages, which is the unit rate and example 9, and you have to put it into your interactive notebook. So it needs to be glued in or stapled in or taped in, and when it's in and you're done with the last set of examples, raise your hand, I'm going to come by and stamp the actual foldable and your notebook to make sure it's in the notebook in the right spot. This goes on a new page, okay? I'm going to give you time to do that.